Hello guys, welcome back to another exciting video. In today's video, we're going to be going over looking at React Agent. We're going to continue with our series of building different agentic patterns from scratch in Python. So in today's video, we're going to go ahead and learn how to implement a React agent all in plain Python code, right? So in the last video we looked at tool calling agents. In today's video we're going to be looking at React agents. So what are React agents, what are they used for, why do we need them, how to build them? We're going to be looking at all of that. Okay, so let's get into it. So again, this whole series on that I've said from somewhere early this year, we have been talking about building agentic AI systems, right? So we started from working with Langflow when we went over different stuff and different things, and then right now we are going ahead and learning how to implement some of these agents in our own Python code, because this gives you more control. And also, once you learn these agentic patterns and how they work in the background, then you have a better understanding of your whole agentic AI systems, right? So let's jump into it. So the first thing that we'll be looking at is basically how to implement this React agent. So let's look at the things that we're looking at in this video. So we'll be looking at introduction to what a React agent, basically what a React agent is. We're looking at setup and installation, bring in the necessary code that we need to set up this. We'll first take our initial steps, like our first steps towards achieving a React agent, and then finally we'll build a custom class that we can use for other projects or in other things, right, that we want to use. So we'll build a custom class that you can just copy and paste over into other projects that you're working with. Okay, so let's start with this. So the first thing is, what is really a React agent? So sometimes, right, if you go on ChatGPT and you ask the question, like back in the days, it just outputs a bunch of information. So this information might be hallucinated. Most of the time it was being hallucinated information. Maybe you ask about what's the current stock price, right? Back in the days, it didn't have access to the internet. So it just goes ahead and output a bunch of gibberish based on the data that was trained on. So it doesn't really think about what you're asking and then carefully plan to answer that question. So React agents, they're also called planning agents, or basically planning agent, because they think about what you say or what question that you ask, and then come up with a bunch of steps to that they can take to arrive at a very good answer that can answer a question without hallucinating so much. So that removes the kind of like limits hallucination and can enables basically agents to do more complicated stuff, right? So that's basically what a React agent is. So basically, if you give it a question, it thinks about it, right? Which is the RE part is for reasoning, it reasons about it, and then the CAT part is for acting. Acting is where it uses the tools to take actions. For example, if I ask it, hey, can you find me the product of 10 and 2? And I built a React agent that has basically a calculator tool, right? So it reasons, okay, the user wants to find the the sum of 2 and 3. Okay, I have this bunch of tools. One of these tools is the calculator tool. Okay, I think I can use the calculator to answer this question. So it then goes ahead and calls the calculator tool, and the calculator tool gets executed. They are executed, right? So it thinks about, okay, I need to use a calculator, right? Thinks about it, or the reasoning part, or the thought process, right? So you can, other people call it reasoning, other people call it planning, other people call it thought process. So it does the whole thought process on how to answer the user question. So user question, add 2 and 3 together. Thinks about, okay, I need to add 2 and 3 together. I have a bunch of tools. One of these tools is an addition tool, or basically a calculator. So I can use a calculator and add 2 and 3 together. So the calculator gets called, it gets executed, right? And then the answer, which is 2 plus 3 is 5. So 5 is the observation. We send the observation back to the LLM and say, okay, you said that you wanted to add 2 and 3 together. Now we have used a calculator tool and you have added 2 and 3, and the answer is 5, right? So the LLM thinks, okay, now I have the answer, which is 5. So I can go ahead and return a final response to this, right? It doesn't need any other tool call, but in some cases it might need multiple tool calls. So it might go in this loop for a while. That's why I say this is optional, because after sending the observation back right here, it thinks again, do I need any other tool call? If the answer is no, it can generate a final natural language response. If a tool call is needed, further tool calls are needed, then it goes down this path of action, right? So that's the ACT part of React, reason and acting agent, or a planning agent. Okay, so now that you have gone over the basics of this, we are not going to be looking at this basically how to do this setup, right? We're going to be ignoring that part in this video. So we have done most of the step up from the last video. So if you haven't checked that, you can go back and see how we went ahead doing that. So we have all the things installed and all the basic components that we need. So we can get started with it. So I'm going to go back in here, go into my agents pattern folder, create a new folder. I'm going to call it react_agent. Okay, and I'm going to go ahead and create a file in here. I'm going to go ahead and create a notebook. So I'm going to go ahead and create notebooks, and instead of notebook, I'm going to go ahead and create a lesson _01.ipynb interactive Python notebook. Okay, so we're going to go in here, add in a documentation. Okay, if you have been following my channel, I've always add documentation just to document everything. Okay, so now that you have understood the basic part of a React agent, it has a couple of steps, right? So I've also written, again, I have articles for all my videos. Okay, so you can always follow along with the articles as well. So I've explained this part to you. So the reasoning phase, right, the thinking, right, which is the RE part of the word React, reason. Right, it's reasons over the user's question and then decides, okay, do I need a tool call for this, or do I not need a tool call? For example, if I ask what's the capital city of Japan, which is the answer is Tokyo, right? You don't need a tool to know that, right? It has already been within its training data, so it doesn't need this part. So that's why I said optional. So it just goes ahead and say, hey, the capital city of Japan is probably Tokyo. Then that's the final response to you. But if it needs a tool call, let's say that the LM for some weird reason doesn't know the capital city of Japan, then it goes ahead and uses maybe a web search tool and then search, hey, what's the capital city of Japan? And then gets the output back, maybe capital city of Japan is Tokyo. That's the observation sent to the agent. The agent thinks, okay, so the capital city of Japan is actually Tokyo, and then generates the final response to back the user, hey, the capital city of Japan is Tokyo. Right, that's basically it. So that's basically the whole process of a React agent, right? Okay, so now let's get started. So I'm going to go ahead and bring in some code that we had from last video. So I'm just going to go ahead and bring in all this code, which is we are using to create a tool. So I'm not going to explain to you what this code is all about. I've explained to you in the last video, so you can always go back to the last video. So I'm going to paste in that code in there and then run this cell. Okay, so I'm going to run that cell and make sure I select the right Python environment. Okay, so once that's running, I'm going to go ahead and bring in a couple of more code, which is this code right here, which also we implemented in the tool calling agents, right? So the reason why we are building, you can actually just think about it. Why do you think we need a tool calling agent? Because a React agent basically calls tools but also applies the reasoning thing to it, right? It's not only calling tools, but it reasons over some task before calling a tool, right? So we need the tool calling agent piece as well, right? It reasons and then acts, right? So that's the acting part is the tool calling part. That's why we have the tool calling agent class that we implemented in the last video. We bring it in here. So if you want to watch that, you can check that out, which is the tool calling agent, right? So okay, I assume you're all on the same page on that. Again, the videos are all on the channel, so you can always go back and check those videos out. Okay, once that's done, I'm going to go ahead and simply copy this and then bring it in here. So I'm going to go make sure I run this cell, and I'm going to bring in those imports, paste in those imports, and have this run. So okay, we have, right, that's fine. So once we are done there, you're going to go ahead and simply create an open AI client. So I'm going to paste in that code and run this. Okay, good. So once we have our clients created, now we can go ahead and define a React prompt. So a React prompt is very similar to the tool calling agent prompt that we did in the last video. So I'm not going to go much into depth about this because you can always go back and watch the last video. So I just modified it a bit, but basically it's more or less the same thing. Right, so we have discussed all this about the tool calling agent. Basically, the only difference we added is these three keys: with the thought process, the action, and observation. So basically, the thought. Carefully reason about the problem and determine if a tool call is necessary. That's the reasoning part. If a tool call is necessary, then the action part comes here. Execute tools based on your reasoning, following the proper format. The proper format is here defined. And then the observation, analyze the results to inform your final thoughts, which is analyzes the results from the tool calling, and then makes things again. Do I need to call other tools, or is this result from the tool sufficient enough for me to provide a user answer? If it's sufficient enough, then a user answer is provided, right? It's that straightforward. So I'm not going to spend a lot of time on this. So I'm just going to go ahead and we just added some other tags here for thought process when the agent is taking, and the response process when the agent is outputting its final answer. Okay, so I'm going to run that. So that's basically it. And you can take some time and read through the prompts. Okay, this code is all available on GitHub. There you can find the link in the description, and you can always also read on my articles. I have this explain this in depth. So the thought process contains basically the agent's reasoning right before taking an action. The tool calls tags basically wrap basically the JSON. We have talked about this in the last video on tool calling. And then the observation consists of the answer that the agent got from the tool execution. And then we have the response tag, which consists of the agent's response, and then the tools tag consists of all the available tools that are available to this specific agent. So we're just going to go ahead and list all these tools in here. Okay, so I'm going to go ahead and simply copy this, and this is very similar to what you have done in the tool calling agent. So run that part. Okay, so now that we have that done, what you're going to go ahead and do next is creating our tools. Again, you have talked about how to create these tools and all this, right? So I'm not going to go ahead and explain this further, because we talk about all these decorators. We created this ourselves, right? So I'm just going to go ahead and skip over that. But basically, we're just creating a tool right here. Right, and if you have been following along with this video from the beginning, you probably know we have seen this syntax in working with things like Langflow, right? So sorry, LangChain. So it's more or less the same thing in here, right? Again, if you don't know, there's this nice framework called LangChain. You can actually go ahead and check. Sorry, not LangChain, Langflow. It's actually very good. Okay, you can check it out. So all this you have done in the last video, right? About the tool specifications or the tool signature. So you can always check back on that last video in case you have any questions to ask. So basically, you're just going to go in here and then add all those together into basically a Python string. Join all the tool specifications together into a Python string. Now that we have that, you're going to go ahead and pass this into our React prompt, replacing the __ tool tag with our tool specifications. So basically, if we go back in here, we are replacing this part, right, with our actual tools, because we said that our tools tag consists of all the tools, right? So that's basically what we are trying to achieve in there. Okay, so once we have that, we are good to go. We're good to go, and we can run this, and now we can see the agent prompt right here. You can see now we have the tools specification actually passed in. Good. So once we have that out of the way, what's next to do? We are going to go ahead and actually we're going to go ahead actually first try our first prompt. So basically our first test, and passing the information right here. So let me just document this part and say this is going to be our first test or first run. Okay, so that's basically just passing a system prompt, which is a React prompt, and then the user question, which is the user question, put it in the question tags. The sum of 10 and 20 is the width of a rectangle that is 100 units long. What is the area of the rectangle? Okay, assume that we don't have any AI systems in the world. How will you answer this question by yourself? Just pause the video and just think about it. How would you answer this question by yourself without using any AI tool or any... Okay, you can use a calculator, but no Googling, no AI. How will you solve this? Right, so the sum of 10 and 20. So first we need to find the sum. So 10 plus 20 is 30. That will be the width of the rectangle, and so that will be the height of the rectangle with the width of 100 units. So you take 30, which is a sum of this, times 100, that will be 3000. So the final answer we expect from this agent is 3000. So there's a reason why I asked this multi-step question, because I've already two tools. So it's going to use the addition tool to add 10 and 20 together and get the observation as 30, and it's going to now need to do another tool call, which is going to take the width, which is 30, minus the height, the length, which is 30, minus times the width, which is 100. That's how it's going to arrive at the final answer of 3000. That's what you expect our agent to do. Now let's test it out. Okay, so once I have that, I'm just going to copy this, and we're going to go ahead and simply run it in here. Okay, run this, and let's see what we get back. So we should do two steps. So you can see here the first step is telling us it needs to add, is calling the addition tool and adding 10 and 20. That's correct, right? Perfect. Now The agent, the LLM itself does not execute the tools. Let me explain this very clearly. Mention this again. LLMs themselves do not execute the tools. They basically point out a tool and its argument that we need to use to call that tool. We call the tool ourselves and then pass the response of this tool back to the LLM. The LLM does not at any point call a tool. I hope now that's a bit clear. Okay, so now that we have this, we're going to go ahead and do what we did in the previous video. Basically, transform this into a form that we can use to call it, and basically call out the function, the addition function ourselves, right? So we're going to do the tool mapping and all those, and then let's see. So copy this. So paste that in here, and then let's run this. So you can see now we take something this, right, this whole thing of tool tag, tool call tag, and then all this, and then cleaned it up into something like this. So add two numbers, which is the name of the function, and it's taking in this argument. So now we can go ahead and actually call that, and then so I'm just going to go ahead and simply copy this. So copy this code right here and then paste it right here. So it's going to go ahead and simply list a list, right? So there can be multiple tool calls, but in this case, the agent is doing it as multi-step, right? So it's doing kind of like a chain of thought, right? So it's doing one step at a time. So it's taking the addition tool, running it, and basically return to us the result. So addition, we are calling the tools.get and then passing this argument, right? That's basically what you're doing. So so it's basically getting the tools list, and it's getting the names from it, and then simply running this, passing the argument, and you're getting the result as 30. So okay, yeah, 10 plus 20, yeah, that's 30, right? So hope my math is on point. Okay, so now that we have this answer being generated, so the agent thought that it needed to add 10 and 20 together, called the addition tool perfectly. We executed the tool, got the answer 30. That's our observation. You're going to now pass this observation back to LLM saying, hey, you asked us to use the addition tool to add 10 and 20. We have done that, and the result is 30. Right, so the agent is going to think, okay, now I have 10 plus 20 is 30. That to make the length of the rectangle. Then the width I'm told is 100. So I need to multiply this tool. So it's going to use the other tool to do the addition, right? So to do the multiplication to find the final area of this rectangle. Okay, so let's go ahead and simply pass in the observation back to the agent. So I'm going to go in here, pass this in, and let me run this again. So you can see here we have passed in the observation as 30, and this was the original question, right? So 10 plus 20 is 30. Now this is the length. Now the width, we said it's also 100. So it needs to go ahead and use the calculate area of rectangle, and from my understanding from high school, you multiply the length times the width to get the area, right? So correct me again if I'm wrong on this, right? So I don't think I'm wrong, but anyway, maybe I'm wrong, just let me know. Okay, so now good. So basically we need to do one more thing. We need to actually pass this observation back to the agent, and then so it's saying this. I don't know why it's repeating what we did again. So it's saying add two numbers. Let me see if we pass the right observation. Okay, so we pass the observation, which is this response, which is 30. So we pass the observation as 30, and then say React agent reasoning acting framework, you blah blah. This is observation, right? So sometimes we really need to play around with the prompts. So we say formatted response. We call this passing the user prompt. The user prompt is okay. I think I made a mistake right here. I need to go ahead and copy this. So I need to copy this, pass it in here, pass this in here, and then say this. So this is our new user prompt, right? So okay, so run this and run this. Okay, so run this again. So now you're good to go. So now it's calling. Okay, now that it has the result of the sum of 10 and 20 is 30. Perfect. So now you got the right answer, right? The sum of 10 and 20 is 30, which is the width of the rectangle. Given the length is 100 units and the width is 30 units, perfectly, right? So I can calculate the area of the rectangle. So good. So it calls the calculate area of rectangle tool, passing it as the length as 100 and the width as 30. Okay, that was a bit messed up, but anyway, it's correct. Because like addition is like I forgot the right word to use, but like you can do it in reverse, right? 10 times 20 is the same as 20 times 10, right? So okay, now that you have that, again you're going to repeat the same thing. Transform this output, right? Copy this, transform the output, and then you're going to use that response, and you're simply going to call, basically run that tool again. So basically execute the tool again. So go in here, execute, we get the product, right? So it's going to take 100 times 30, that's 3,000, my bad. So once we have the result in here, we're going to go ahead and repeat the same process. Now go ahead and do this again. It is basically adding the observation, which is a tool called results, and then repeat the process. So now that we have this, now you can go ahead and simply call this model one more time and see. So basically we got the results, observation, you're passing back to the model, which is a thinking again, and let's see what it does this time. So run again, and okay, so we get the response. Let's try to print out the response and see what we get back. So I'm just going to go here, print out the response. So the area of the rectangle is 300 square units, and you can see it's using our response tags as we instructed it within the prompts, right? So that's perfect. That's the right answer. Yeah. So that's basically how a React agent works. So in case maybe the question was a bit more complicated and you need to call other tools, they need to go down this optional path again, and then the press will repeat X amount of times, right? So this time you have done everything manually, doing everything manually. So in most cases you won't do everything manual. Like imagine there was 10,000 tool calls, like you would be copy pasting the code 10,000 times. That's ridiculous, right? So we are going to automate all these things and write a class to help us achieve that. So okay, so I'm going to go inside of my React agents. So I'm going to go in here into our Python classes, go minimize this, our Python classes, create a folder in there called React underscore agent.py. A React agent, sorry, folder, and then in that folder I'm going to have underscore init underscore .py file, and within this file I'm going to simply copy this content and simply paste it in here. So don't worry about what this is, we're just going to go ahead and do that. So say agent.py. So agent.py, you're going to go ahead and grab all this content. This is a content of agent.py, which is just the same class that we wrote in our notebook, right? So it's just, you can just copy it from the notebook if you want to. I'm just gonna copy it from here just to save some time. Okay, once we have that, now we're going to go ahead and simply run a test. So copy all this. So this class that we have, I prefer that you use the one that is discount, because I've added some colorama to make some coloring and make it look better, like colorama. So make it look better and stylish. Okay, more like Langchain. Okay, so once I have it, I'm going to go into a file called let me scroll down all the way here. I'm going to go into test and then create React underscore agents.py. So I'm going to go into test and then create a file called React underscore agents React agent.py, and then paste in this code right here. Okay, so okay, I need to change this to be React agent, so I can say this to be React. Let me see if I got this right. So the spelling right here is wrong, so I could change it here, or I could change, let me just change the file name just to stay consistent. Okay, so I'm going to change this to be React, let me see, React agent, then save that. Okay, awesome. So once that's done, I can just go ahead and execute this. We can go ahead and execute this code right here, and yeah, we can just go into our terminal, which I have opened up right here. I'm going to go into my test folder and make sure that I activate my right environment, right? So I'm going to say conda deactivate to deactivate the base conda environment, and I'm going to say conda activate. I call this multi-agent. I have it right here. Let me go back to the notebook. Not here. Let me see if I can open up this React agent. Open up this multi-agent patterns tutorial. Okay, multi-agent patterns underscore tutorial. Tutorial, did I say tutorials? Okay, tutorial, run that, and that should activate our conda environment. Once that's activated, I'm going to do Python 3, and then we're going to call this one a React agent.py, and then run that. So you can see it's going to the first iteration, and you can see now it's basically called the tool. Yeah, so we got the final answer there. So basically this it goes it's just a bit too fast. Now this is our question, so this is a thought process of the agent. So I thought to find the area of the rectangle, I need both its length and width. The width is given as a sum of 10 and 20. I will first calculate this sum and then use it along with the length to find the area. That's the thinking behind it, bro. So it goes ahead and just simply say, hey, to do this, first do this summation. I need to call this add two numbers tools and pass in these values, these arguments, and it calls the tool. The tool gets executed successfully. Return the result of 30. We then pass this as an observation, right? So go back here, pass an observation back to LLM saying, hey, this was the answer. So now it goes ahead and say the sum, it goes ahead and say this observation, the second iteration. Right, so that was the first iteration. Now it's going to the second iteration, and this is the observation. The sum of 10 and 20 is 30, which is the width of the rectangle. The height of the rectangle is given as 10 units, 100 units. And then this is the thought of the React agent. Now that I have both the length and the width of the rectangle, I can calculate the area using formula area equals to length times width, right? Something we've been taught in high school, so primary school, in fact. So length times width, so it has all the things that needed. So it calls the calculate area of rectangle add tool, and then passing in 100 and 30. And then this tool gets executed with these arguments, which does the multiplication. Okay, so you can see we are doing this is all that we have implemented in the last video about for tool calling agent. So it goes ahead and say tool calculate area of rectangle executed successfully. Result is 3000. So what goes ahead and simply say, oh, result is 3000. That's the observation. That's a third iteration. Now the area of the rectangle with sum of 100 and area of length of 100 and width of 30 is 3000 square units. Perfect. So that's the second iteration. So it goes back in here. Now it has this observation. Do we need any other tool call? It thinks no other tool call is needed, right? So I can go ahead and return the final response to the user. So it goes ahead and say the final response. The area of the rectangle is 3000 square units. The area of the rectangle is 3000 square units. That's the final answer. That's how a React agent works. Yeah. So that's all I wanted us to cover in this video, how to build a React agent from scratch, right? So I hope now you have understood how a React agent works. So anytime you work with a library like LangChain or LangFlow, you're really understanding what's really going on. This is basically what's going on, right? So this might be a bit rudimentary and not very like production ready, but it's just for you to understand basically how this works. And if you decide to build anything yourself, you can go actually write at the code, your actual code to build something like this yourself. This is just for you to understand the basic concept. It's not like I'm building a production ready library. No, it's just for you to understand how this works in the background. So that's all I wanted us to cover in this video. Yeah, so thank you guys so much for watching, and if you enjoyed this video, show us so many bits of support. The simplest way you can support the video by the video is simply by liking the chat, by liking this video, right? So so you can reach more people who want to know such content just like you, right? So you can do that just by simply liking this video. Let us know in the comment section below what's your opinion of this video. You can also follow me if you like reading articles instead of watching videos, or prefer reading to watching videos. You can find me on Medium at Prince Grumper, right? You can also follow me on YouTube, hopefully when you're watching this video, at Coded Prince. You can also follow me on X, or aka Twitter, at Prince_Grumper. So yeah, on Twitter I don't do much. I just really enjoy the memes and post memes, and also upload post video links whenever I post videos and articles on Medium as well. Yeah, and if you have any like something that you want us to talk about, to like questions, feedback, suggestions for future videos, you can always follow me, or you want us to work together on anything, I'm open to that. You can follow me on LinkedIn at Prince Grumper. Yeah, that's basically it, and thank you guys so much for watching this video, and I hope you find value out of this. See you in the next video, and keep safe, right? Cheers guys, happy coding.